Hey there guys, this is video number 3 in the Stats 1020 comprehensive review, okay, in preparation for our final exam. So far we've reviewed chapters 1 through 9, and in this video we're going to cover all the hypothesis tests, several sections worth, and probably the crowning jewel, if you will, of the course. So all the work that we've been doing so far leads to this, finally, the essence of research, right? So a lot of researchers, what they do is they come up with hypotheses and then they go out and they test them. That is the essence of statistical and scientific research. So, and also research in other areas as well. Didn't mean to say scientific and leave out our friends in social sciences, for example. Okay, so this gives us a quick overview here of the steps for hypothesis tests. So remember, I present us as having 5 steps. If you take somebody else for the course, they might outline maybe 4 steps, or maybe they reword things. I present 5 of them. So if I ask you to provide me with a hypothesis test, you're going to show me my 5 steps, okay? And they are indicated there, and we've talked about them considerable. Now, these 5 steps are exclusive to sections 10.2, 10.4, and 11.1. We have to make little change when we get to 10.6 and 10.7 on the chi-square. Specifically with step number 4, we don't say compute the p-value, but instead we say we compute the, or obtain the critical value. That's what it's called in the chi-square test. Okay, so that is what we're looking at here. So again, 10.1 just kind of sets the stage for some of that work, and 10.2, 10.4, and 11.1 actually outline some specific tests. So we've got different types of hypotheses, okay? Specifically, we're looking at the alternative, the HA. Remember, the alternative is always the research hypotheses. The null is always the status quo. So the two-tailed one is where the alternative is the not equal to. And the alternatives that we have for one-sided or one-tailed is where we see the inequality is greater than or less than. So you should be able to identify a one-tailed or one-sided versus a two-sided hypothesis test rather easily. On this slide is some important pointers, okay? And you'll notice the first one, we've got all caps with a typo there. Sorry about that. So we've got the hypotheses are always statements about the parameters. So that's all in caps. So I'm yelling at you. Very important. This means you're only using the variables mu and p in the hypotheses, so very, very important. So I don't want to see x bars or p hats floating around in the hypotheses. Always about the parameters, okay? Alternative is always the hypotheses we want to test. Okay, null always has the equality symbol. Make sure you're dealing with a mean or proportion, so you're looking at keywords. Make sure to always use the parameter with the central limit theorem when we're computing the test statistics. That's very important. Always use the parameter when we know it. Remember that the conclusions are reject the null or fail to reject the null, so write them out completely. And make sure you remember your cases, area left and area right. Okay, those are your one-tailed or one-sided, and then area in the tails would obviously be the two-sided or two-tailed tests, and that's always based on the alternative hypotheses. What we've got here are just the formulas, okay, and some other pointers here about when we reject the null hypothesis or when we have significance. So we looked at means and proportions. So this is sections 10.2 and 10.4 respectively. Okay, so just reminders there. This information is also found on your formula sheet as well as the hypothesis testing cheat sheet. Don't forget to go back to that. Might be something to have handy as you begin your review. And in fact, this is where I pulled the charts from were for those. The test number 3 here, 2 means, this was in section 11.1. Okay, so this was an 11.1 topic. So really follows the same procedures that we had before, but some different formulas here. But otherwise, the hypotheses are set up one-tailed or two-tailed, all mean the same thing. We reject the null for the certain, if the p-value is less than the alpha level, all of that is still intact. Okay, so nothing is different there. So again, make sure to reference that. But again, that was section 11.1. Another topic we talked about was error types. Okay, so don't guess on these. Make sure you write out the hypotheses so you got a clear indication of what we're trying to study here. And then you've got 3 different answers. It's either a correct decision, a type 1 error, or a type 2 error. It's not a combination of those. They're all exclusive answers. So Make sure you take your time with them, write them out. And we've got the chart, of course, that's provided on your formula sheet. And then this is just an example of a hypothesis test that's worked out, just so you can see all the different bits and pieces, because this is a complicated process to these. A lot of work, a lot of steps, so that's why that's here. So make sure you take a look at that, you understand and remember how to put a hypothesis test together. Okay? All right, and then we've got two more hypotheses here. This was from sections 10.6 and 10.7, which dealt with the chi-square distribution, completely different type of distribution. And we use this test to do two types of comparisons. So the first is to compare a frequency distribution that an experiment produces with what theoretically should be expected. That's known as Goodnessoffit and is focused on 10.6. And then the second one here is to assess whether two traits or characteristics in the population are associated. And that's known as the test for association in 10.7. Or you can say test for independence. That's another way to frame that. In the Goodnessoffit, the hypotheses, remember, they take on one of two forms, regardless of what we claim or what we want to test. So this is a little different now. So it doesn't matter what we think is going to happen with the data. There is a specific structure that the hypotheses have to take with chi-square, Goodnessoffit, and test for association. So make sure you pay careful attention to those, especially in 10.6. And the guided notes do a nice job of outlining those steps. So please, please, please make sure you take a look. And this is just a overview of the 10.6, so Goodnessoffit possibilities here. So especially pay attention to when we reject the null hypothesis, because that is different than what we dealt with in 10.2, 10.4, and 11.1. Okay, especially those formulas all found on the formula sheet. And we've got one for... Oh, we're coming up to the association. I was waiting for the association slide, but it's coming. So in the test for association, the hypotheses are always stated in this way, where the null is the two variables are independent, or you can say the two variables are not independent, or you can say for the null there is no association between the variables, and for the alternative there exists some association between the variables. Okay, so we want to avoid the word of dependent in the alternative hypothesis, because remember that hypothesis never proves anything. We have to do some additional research, repetitive trials, all of that good stuff to really definitively come to that sort of a conclusion. And this is the slide I was anticipating. This is the formulas for section 10.7, as well as some extra tidbits on the chi-square distribution. So that rounds out hypothesis tests. So we've explored 5 different tests for the course of the semester. So make sure you take a look at those. Print out that hypothesis testing cheat sheet. Very, very important resource for you to have in review. And what we're going to look at next on the final video is just Chapter 12. So Chapter 12 is pretty special to get its own, going to be a pretty short video and overview.